Okay. So what we want to talk about today is we want to talk about solving systems by graphing. Okay, we've been graphing for a while here in Unit 2, or Mod 2, Unit 1. Today we want to use graphing to solve systems.
Are these notes?
These are your notes.
Do you have homework tonight?
You will. Okay? 2 or more linear equations form a system. So you can flip your notes over to the back side of the first page. Yes, sir. Okay? You got the notes, you just got to follow along. It should be in order. This is the back of the first page. Okay? You have everything. Mine's going to come up in pieces. Okay? You didn't go pick up the notes, Nelson? Okay. 18 students will ever rate it except one. Who's the one who cuts the issues?
I got the other one.
Okay.
You have the graphing paper? Yeah.
All right. Here we go. Okay. We've dealt with one equation. We did the slope-intercept where we graphed. Today we deal with the fact that we got 2 equations at a time. So 2 or more linear equations form a system of linear equations. Any ordered pair that makes all the equations in a system true is a solution. And that's what we're looking to find today, is we're looking to find the solution. The ordered pair that makes every equation in the system true. Okay? One way we have to find a solution is by graphing. And that's what we're going to do today. So in problem 1, the system is y equals 2x plus 4 and y equals x plus 2. We would like to find out what ordered pair makes both of these equations true at the same time. And the way that we're going to do it is by graphing. So, let's do y equals 2x plus 4. Who can tell me what the slope of this line is going to be? 2 over 1. It's what's in front of the x, Murray. Guys, what's the intercept going to be? 4. Remember, y equals mx plus b. The number in front of x tells us how to get from one place to the next. The number that doesn't have a variable on it tells us where to start at. So we're going to start this graph at 4. Do we start x or y axis?
Y.
Correct. So we go to 4 on the y axis. We put our first dot there. How do we find the next points on the graph then? Correct. We go up 2 and right 1. And how many points do I like to have on your graphs? 3. So to find your 3, just keep it going. It is supposed to be on the 4. Mine is a little off. And you do want to be very accurate with these today, so rulers would be a great thing to have. So use the rulers. Again, like we talked about last week, arrows on the end, because these are going to continue forever without stopping because they're lines. Now, here's the new twist. We have 2 equations in a system. We graph the second equation. Ladies and gentlemen, what's the slope of our second equation? How do I make it a fraction? Put it over 1. What's b? Very good. So once again, you know where to start. It's a 2. The number in front tells you how to get from place to place. Okay? Just like if someone came in and said, how do I get to the cafeteria from here? You would say, okay, you go out this way, you turn left. You go down to the hallway. When you get to the top of the steps, you turn left. It's directions. Okay? We just don't have to spell out as much because we know that the top number tells us how far we're going to go up and down. The bottom number tells us how far we're going to go left and right. So this is going to start at 2. Up 1 and right 1. And again, I like 3 points. You can get as many as you wish. Accuracy is key here. here's the trick. The solution of the system of equations is an ordered pair that makes all the equations true. So if you look at this blue line, there's an infinite amount of points on here. There's an infinite amount of points on the red line. Which point's on both? Which point is on both the red and the blue line? Correct. So your solution is negative 2, 0. Can draw a better 0 than that.
Are you taking a video?
Yes.
It does every day. Can they hear us?
Sometimes.
Can they hear us now?
It's the point of intersection. Where the two lines cross at is your solution. So you're going to graph your two lines like we did last week. You're going to tell me where they cross at, because that's your point of intersection. That's the solution. That makes both equations true at the same time. Questions about problem 1? Okay. Accuracy is important. Use your straight edges. Okay. Get 3 points if you can to make your lines as accurate as possible. Okay. Questions on the first example? All right. A system can have the following types of solutions. Okay. It can have, like we just saw in problem 1, it can be independent, where it has one solution, where they cross at. It can be what we call an inconsistent system. It has no solutions because the two lines are what? Parallel. What does parallel mean?
Side by side?
Side by side. Give me more.
They never end.
They never meet. Okay? So if we're looking for the point that they have in common, if they never meet, then you have no solution. Okay? Or they can be what we call a dependent system. They're the same line. When you graph the two lines, they will fall right on top of each other. And this, does anybody know what this symbol means?
Infinity.
Infinity. Has infinite solutions. Okay? Now, you guys are right. Parallel does mean side by side, and it does mean that they never meet. What else is true about parallel lines that we know? Or do we know? Well, take a look at your example of parallel lines. Okay? Guys, how would you describe the slope of this blue line? Give me directions. Slope means directions. How far up, how far right?
It's going up very, 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 very fast.
How much?
I can't see that far.
Look at your paper. It's the same one on your paper as what I have on screen.
I didn't see that.
Yeah. I'm talking about the slope. Yeah. So it kind of looks like we're going up 1 over 1, doesn't it? How does it compare to the slope of the orange line, which I know yours isn't in color, but the same.
What's that? Why do you got the forever symbol right there? Infinity symbol.
Because that means on a system like this
Yeah.
is infinite solutions, because they're the same line. The lines are right on top of each other.
Right.
Okay? All right. Let me ask you this. Looking at this inconsistent system, we notice that the slopes are the same. Are the intercepts the same? Do they cross the y-axis at the same place? Again, you got the thing on your paper, so you can write this on there. Blue crosses here, orange crosses here. They cross at the same place? Yes or no? It's a simple question.
Yeah.
They do?
No.
No. So they have the same slope. They have different intercepts. For a one solution, they have different slopes. If you look at this second independent system, the orange line's going down, blue line's going up, different slopes. It's a one solution. Here, on the same solution, or excuse me, Infinite solutions, they have the same slope and intercept. Okay, I remember how to write it in. Types of answers you can have. You can have no solution, parallel lines with the same slope with different intercepts, one solution where the lines cross because they have different slopes.
So we have to just find the slopes of these.
That can help you, yes.
I don't understand it.
Okay. Tell you what, Murray, can you give me like 2 minutes to work to the next slide, and I think I can explain it.
Yeah.
Okay. All right. Everybody got these things written down on your notes that I wrote up there? Okay. All right. Yes, Nelson. In about 5 minutes or so. Do you have your agenda? Then I should say in about 45 minutes. Because that would be the end of the period.
Yeah.
Okay. All right.
About 5 minutes?
Problem 3. What is the solution of each system in parts A and B? Use a graph, describe the number of solutions. So Murray, you asked the question, do we just have to look at slopes? And the answer is yes.
Yeah.
Ladies and gentlemen, look at A. Y equals negative x minus 3, and y equals negative x plus 5.
Negative x over 1.
So what's the slope of the first one? Negative 1 over 1.
And then.
Second line? Good. So since the slopes are the same, that tells me that we're going to have either no solution or infinite solutions. Look what we do. What's the B?
-3.
What's the B? What's the second B, guys? 5. So, are the slopes the same? Yes. Are the intercepts the same? No. This tells me that we have no solution. Now, we can go ahead and graph these. So we start at negative 3, and then we go down 1 and right 1. And our second one starts at 5, down 1 and right 1. Again, arrows to the end because we're going to... No solution. Lines never cross.
I thought it was infinite.
No. For infinite, both the slopes and the intercepts have to be equal. This has same slopes but different intercepts. That's no.
That's no solution?
Right. Okay. All right. Take a look at problem B. Problem 3B. Y equals 3x minus 3. You can tell us the slope. 3 over 1. Who can tell us the intercept? Negative 3. Very good.
How did this,
Second equation. 3y equals 9x minus 9. Is that in slope-intercept form?
No.
So what are we going to do to make it that way, Carter?
Divided by 3.
Correct. Remember, you want them to look like this. Y equals mx plus b. And remember on division, you do not have to match like terms. You can divide 9x with an x by 3 without an x. This division.
3 be up top. For that. 3 over 1.
What do you mean you got me confused?
You said you want you want it to be just the x there. Why can't you have a 3 up there too? 3 over 1.
Okay, keep talking. Keep going. I'm just a little not feeling well yet, so
You know, y equals 1x.
yes.
Why do you have, well, then why'd you just say you wanted to look like that if you can have the 3 up top for the 1?
Okay, so why'd I make it a fraction when it wasn't?
Yeah.
Because when you do slope, you got the rise and the run. How far up and how far over, so that's why you need 2 numbers.
Yeah.
That's why I always put them over 1 to make them fractions.
Alright.
Okay, Nelson, you're not going until I'm done teaching, so. Well, I understand, you have a 5-minute passing period before class, that's when you should have gone. Okay? Okay. All right. So ladies and gentlemen, let's finish up this red equation. What's 9x divided by 3?
3.
What's negative 9 divided by 3?
-3.
Guys, what's the slope?
3 or 1.
Yes. What's the intercept?
3. -3.
Notice that your slopes are the same, so are your intercepts?
That's gonna be, infinity.
Correct.
I'm gonna get that infinity symbol on my wrist. Get tattooed right there.
Means you have infinite solutions. Because the slopes and the intercepts are the
I
same.
got infinite.
That is your lesson for the day. Questions? Yes, Murray.
Remedy?
What?
Like an old, you wanna know an old remedy? You know it's good for